Now let's look at the solutions that we can have or we will find for an LP problem. The basic solution for an LP problem is called a feasible solution. A feasible solution is one where the values for the decision variables, x sub 1, x sub 2, x sub 3, x sub 4, can be any number. The values for the decision variables are such that each and every constraint is satisfied. All of the constraints are satisfied. Then that solution is called a feasible solution. And as we saw in the graphical method, there could be a bunch of those solutions bounded by flat surfaces, and that region of that contains all the possible feasible solutions is called a feasible region. And from the edges of the feasible region, the corner points is where an optimum solution will be, and there are three different scenarios for optimum solution, or four. The first one is unique optimum solution, which is what we found in the graphical example that we saw, where x sub 1 was 560, x sub 2 is 1200. There's only one solution that gives you the maximum profit. Now there could be multiple optimum solution situation where there is more than one. And then there is what is called unbounded, where you can increase the profit line without any limit. Of course, when that happens, it's not really practical. So what that would mean is that you've somehow overlooked some constraint somewhere and you're ending up with an unbounded situation. So when you have unbounded solution, unbounded optimum solution, that really means that your model is incomplete in some way. Okay, let's look at an illustrate. Let me illustrate how the multiple optimum solution will work. Suppose if this is the feasible region, so you have the blue line up to here and then green and then red, so this is the feasible region. Okay, now you bring in your objective function line. Suppose if this is the objective function, now you're trying to maximize. Okay, so you start moving the objective function line this way. So the ISO profit line is now being moved, and you see that at the edge, okay, as it increases, it becomes parallel, it coincides with this constraint line. Now if you try to increase the profit anymore, it's going to leave the feasible region completely. So at this point, the entire edge here, starting from that point all the way to this point, they are all optimum. They all give the same maximum ISO profit. So in multiple optimum solution situations, you will have 2 points on the line and every point in between. So there's infinitely many optimum solutions. When you do this in solver will only give you one solution. You wouldn't know whether we have a multiple optimum solution or not. But in graphical representation, you can see what it means, the multiple optimum solution means. Now unbounded solution, here is an illustration of unbounded solution. Suppose if you have a constraint and all points this way are feasible, okay, and another constraint, all points this way are feasible, and then you have the ISO profit line. Now if you try to maximize, and as you see that there is nothing bounding anything on this side, so you have an unbounded feasible region. So theoretically, the objective function line can be increased without bound. So this situation is called unbounded solution. Of course, this actually means that we have overlooked some constraint and the model is incomplete. So you have to go back to the model and see what changes you'll have to make. So model is incomplete is the actual reason for unbounded solution. Now infeasible solution, here is an illustration of that. Again, look at a constraint like this, all points below satisfy constraint 1, and then here is another constraint, all points above satisfy this constraint. So you have no point that satisfies both constraint 1 and constraint 2. So that means there are no feasible solutions at all to the problem, so it is a infeasible situation. And this typically means that there is some error in your model. So you have to go back to the model, look for the error and fix it. So in summary, for an LP problem, you may have a unique optimum solution, or you'll have multiple optimum solution, or you'll have an unbounded feasible region and an unbounded solution, which means your model is most likely incomplete or erroneous, or infeasible region, which means your model has some kind of error.